All right, so of course the demo today is a combination of demonstrating HSRP, which is Hot Standby Router Protocol, and also a bit of a demo for the Prac test as well. Now this demo is going to be pretty much more complex than what your actual Prac test will be, because as you can see here, I've got 3 routers up the top just to make the HSRP sort of worthwhile. And so from but apart from that, you know. So just get it. This is more complex. This is more complex than what the actual practical test will be. So as you can see, I've got 3 routers at the top. There's 2 routers that I'm going to make redundant for one another, and of course they've got separate links to an ISP. So again, some good redundancy. I suppose I could have had 2 ISPs, but you know, how big a world do I want to build? So as you can see here from the addressing, there's 2 VLANs I'm going to create, VLAN 10 and VLAN 20, one on 2.168.10 and one on 2.168.20. I think you've seen my addressing scheme like this before. And so router 1 will have a .1 on all of its interfaces, except maybe a link to the ISP. And router 2 will have a .2, and we will actually create virtual routers which will have an IP address of .3. And so that's actually how your first hop redundancy protocols typically work, is by creating a virtual router that the 2 or more routers sort of manage as a team. And so that virtual router is actually sort of taken on by the active router, and of course is kept track of by the standby router. And so basically from there, so that virtual router, I'm going to use a .3 address. And so it's actually the .3 that you tell your hosts. And so if you tell all your hosts their default gateway is 192.168.10.3 or 20.3, either router 1 or router 2 will actually be running that virtual router for the redundancy.
So is the 2 routers going to be in the same subnet, is it?
Yeah. They'll each have interfaces on both VLANs, and through those interfaces they'll actually keep track of one another to make sure that, yeah, that the active router is running, basically. Now, also, if you remember, I hinted at spanning tree, playing around with different routes for different switches. While that example I gave before was a little bit illogical, this one is basically what you do in the real world. And so I've got 2 core switches, again with redundancy. And so what I'm going to do is for VLAN 10, I'm going to make router 1 the primary router or active router. For VLAN 20, I'll make router 2 the active router. And so again, we've not only just got redundancy now, basically, we've paid for 2 links to the ISP. Well, all VLAN 20's traffic will use that link, and all VLAN 10's traffic will use that link. And so we're load balancing as well as having redundancy. And so it certainly does give some flexibility to the situation. And so tying spanning tree into that, I would make core 1 the route for VLAN 10. So that would optimize all traffic's routing to the core 1 router. And then, of course, router 1 is the primary router for that VLAN. And so the traffic will flow nicely to that switch, then to the router, and work very efficiently. And I'll make core 2 the core for VLAN 20. And so again, all the traffic for VLAN 20 will the center of the universe for that, of course, is going to be core 2. And of course, it's directly connected to router 2, and so it will move that traffic. And also, it will actually, spanning trees running. I actually haven't configured these devices at all. All I've done is plonk them on there and I've plugged cables in. That's all I've done, and put a lot of comments around. I haven't actually configured these devices in the slightest. And so this is the default setup. I did look at it earlier today, and switch 3 is actually the spanning tree route at the moment. I didn't manufacture that. That's just the way it happened. I actually put the core switches on first. So, yeah, don't ask me why, but that's the way it's turned out. Obviously, the MAC address of switch 3 is the lowest of the 5 switches I've got there. That's yeah. So yeah, so that I sort of, when I was demoing it earlier today, I said, well, it's got no orange links on it. I'm guessing this is the root switch. And yeah, that's what's happened. So I've got some VLAN 10 hosts. I've got some VLAN 20 hosts as well. And so we'll make sure that they're all working. Now, later on, we'll implement. So I've got sort of basically basic setup here. And then I've got later on doing some more involved stuff. And so down here, we'll actually get HSRP running. And then we'll play around with spanning tree. We'll also get Dhcp running, because that's another topic that we've got, of course, for the in the course. And there's Ether channel as well. So I've got the two links between the two core switches, and so that's a wonderful candidate for an Ether channel. All right, so let's get going. All right, so the ISP router, I'm going to say it's got two active links, G000, it's got an address, G001, another address, which is specified on the table there. I've also created a loopback interface. Now, I think I've mentioned loopback interfaces before, but not so sure I've mentioned them for a router. So, of course, loopback on your host machine, normally 127.0.0.1. On a router, it's basically just a logical interface, but you can give it any address you like. And so, as you can see, I've chosen 200, 200, 200, 200. But it could have been anything. I probably should have put 22222 just to type it quicker, but anyway. And so that's just a logical interface. The reason I put it there is so that we can test that we can get to the internet. I'm not going to have network 200 in any of the routing protocols at all, but we will have some default routes to test out. Now, I've had to do some routing on this router because it's not directly connected to those VLANs. For anything to talk, it needs a route to it. So I've actually put in two routes for each of the VLANs. And so 10.1.0.2 is actually over this link here to router 1. Now VLAN 10, of course, that's router 1. I'm going to make that the active router for it. So that is my primary route for VLAN 10. But a secondary route will actually be via via router 2. Now, this 100 here is actually what's called administrative distance. The lower the admin distance, the more reliable that link is. So the default setting for a static route is actually 1. I've put an admin distance of 100. So this is what's called a floating static route. So if there's no better route, it will use it. But if this route is active, which is the same destination, just with a... Sorry. Well, so this is, of course, via router 1. If that's active, it'll be there. So this one won't be used. But if that one disappears, so let's just say the link between router 1 and the ISP dies, this one will kick in and will send it via router 2. So again, via router 2, of course, no, this is router 1, sorry. This is the route to VLAN 20 via router 1. And of course, that's again a less than optimal route. So that's going to be a floating one. Of course, this one to VLAN 20 via router 2 is the primary. And so that'll have a cost of 1. So I'll show you in the routing table a bit later. All right, so we'll paste it in. Now up here, I don't see any errors. It's all good. Let's do show IP route, see what's going on. The only interface that's working is the loopback. Because I haven't configured the other routers yet, those links aren't up yet. So the only thing it can talk to is itself. And so that's the only link that's available. And so that's that loopback interface I created. So that's it at the moment. When I configure the other routers, more will appear in that routing table. Now, router 1. Now, of course, we've got the link to the ISP. That's what this first G000 is. So the other one was 101. This is 102. And so that will bring this link up. And then on G001, that's where the VLANs are going to be configured. So we've got the sub interface of VLAN 10. Of course, we do the .1Q encapsulation command, telling it's VLAN 10. We give it an address. As I said, router 1's going to have .1 for its addresses. And then VLAN 20, another sub interface with the encapsulation command and its address. And then, of course, we need to turn the actual physical interface on. Now, this is a static route, but it's actually a special kind of one. This is what's called a default route. So basically, IP route is the command. The first address you supply is actually the destination network. The next thing you supply is the mask for that destination network. And then it's the next hop. And so that's, of course, the ISP. So what you're saying with quad 0 is, with a 0 length mask, is that's the rest of the world. And so that's why you'll actually never see an item addressed with quad 0 or actually just the first octet of 0, because that's actually been set aside as being the internet. And so basically the rest of the world is via the ISP. No big surprise there for most of us.
Did you say 10.1.02 was the ISP for?
No, that's on this end. That's router 1's address.
Okay.
On the other end of the link, that's the ISP. That's the ISP's address.
Oh, yeah.
You don't send it to yourself. You send it to the ISP. Next hop IP address. That's what that is. So let's paste that in. And so the routing table on ISP will actually get a bit better as well. So we've got the link to the ISP working. We've got the two sub interfaces configured. We've got it turned on. We've got a default route and status changes for some interfaces. So if we do show IP route here, yeah. So we've got the link to the ISP. We've got VLAN 10 on that sub interface. We've got VLAN 20 on that other sub interface. And we've got the default route. Now, S, of course, means it's a static route. That's where it came from. The star should be up here. It actually means, where is the star? Oh, there. Should have made it a bit wider, shouldn't I? It's a candidate default route. And so gateway of last resort is something, and so that means that there is a default route. If I didn't have a default route, it would actually say gateway of last resort is not set. But now I've got a default route. It's actually got that. Now, this routing, you won't actually need to do in the Prac test. I've just had to do it because I've got 3 routers and they're not all directly connected to everything. So that's why I've had to do it. You don't need to necessarily know this. We will actually cover this next semester if you come back. Okay, so the routing table is at least a little interesting. If we look at the ISP, its routing table will have changed as well because we've got an interface, a physical interface up now. And so we have the 10 network to router 1 is up. And we actually have 2 static routes working. Because the primary route for VLAN 10 is available, because that's going to router 1. Also, the secondary route, as you can see, that's that cost of 100 or administrative distance of 100. So that is available because, hey, I don't have a better option. So that's the only option I've got. So we can actually get the VLAN 20 now. Not that I've defined it yet on the switches, but anyway. And of course, we've still got the loopback. So the routing table is coming along. So router 2 is not greatly different to router 1. .2 for most of the addresses. Static route, or the default route, is just to that different interface there. But all good. So copy. And paste. So again, no errors, lots of status changes. Let's do show IP route. So of course we have the WAN link to the ISP. VLAN 10, VLAN 20, and a default route. Now, if we look at ISP, the routing table actually will have changed again because we've got a second interface. So we've got that extra link to the router 2 now, so router 1 and router 2. You'll notice that the static route has actually changed. These were both by 10.1.02. Now one's by 10.1.02, the other one's by 10.2.02. Because now the primary link is available. And so that's why the routing table will stay for ISP. It's the last time I touch ISP. All right, so that's the basic setup for the routers. I haven't done anything with the switches yet. So on the switches, of course, we've got two VLANs, accounts and sales, and so we need to create those, VLAN 10 and VLAN 20. We need some trunk links, because I haven't done any of that yet either. And so we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 links that need to be trunks on each one. So I've got an interface range command. I think I demoed this last time. So G101 to G106 is the range. Now I'm making it into a trunk, and it's just, if you remember from a few weeks ago, it's one of those switches that needs to have its encapsulation configured before it'll let you make it a trunk port. And on core 1, I've also got this host using port 10. And so I'm just making an access mode port and VLAN 10. So that's all I'm doing on it. 6 trunk links, or creating the VLAN, 6 trunk links and 1 access port. Okay, so I don't see any errors. Core 2, much the same, just that port 20 is for VLAN 20. That's the only difference, really.
Do some switches actually have that many gigabit ports?
Yeah.
Right.
You can have, look, core switches are often modular. You can actually add cards with 48 ports on them. You can have multiple cards on them. All right, so I've just done the 2 core switches. So I might just sort of fast forward time to get everything a little more stable again. Now I haven't played with spanning tree yet, so again, switch 3 is the route for spanning tree. Now the access switches, I've actually got the same config for all of them, and so they've got 2 trunk ports, as you can see. They need to have the VLANs defined, of course, and port 10 is in VLAN 10 and port 20 is in VLAN 20 because I've got port VLAN 10 and VLAN 20 hosts hanging off of them. So I'm actually going to use the same config for all of them, just to speed the process up. No editing required. No errors, all good. Again, all good. See a lot of spanning tree messages there. And yeah. All right, so it's all a little bit confused again. Trunk links, multiple VLANs, all that kinds of stuff. So of course, spanning tree has not changed yet. There's still 4 links that are actually being blocked, are in blocking mode. And so out of the 1, 2, 3, 4, 5, 6, 7, 8 cables, 4 of them are inactive. So not getting value for money at the moment. All right, so that's the basic config done. It would all work, but the redundancy isn't at its prime at the moment. Now, the config there. So, all you need to get HSRP, Hot Standby Router Protocol, is this line here. That's all you need for it to run. So standby, have a number that you share between the routers, tell it its IP address, that's all you need to do. But of course, that's basically leaving it to who's got the highest IP address, who's going to be active. Not a great way. And so you can set the priority to 200. The default is 100, and so the higher the number, the more likely it will be the active router. And then we've got the preempt command. So this actually isn't in the slideshow. It doesn't give you any. It does talk about the commands, but it doesn't actually show you an example. So the preempt means if this router is up, preempt, I want a new election, just so that router 1 will always be the active router for VLAN 10. Now for VLAN 20, it's going to be the standby router. And so just that one line, different number because it's a different interface, different group. And so I've just used the VLAN numbers because, hey, why not? Easy to keep track. So that's router 1. Router 2, we've got VLAN 10. Of course, router 2 is just going to be the standby for VLAN 10. VLAN 20 is where you need all these. You need the priority and the preempt. Now, I've got commands in there, standby version 2. I haven't tried it in the latest version of Packet Tracer, I know. But last time I tried it, it doesn't actually support version 2 of Packet Tracer. You've got a router that was built in the last 5 years, it probably will. Yeah, Packet Tracer does not. No, we can't actually see the difference. So that's basically how we're going to get it running, and that's what we'll activate. So you can see that the IP address here is always the .3. So that's that virtual router IP address, and that's what's going to be shared between router 1 and 2. But it's going to be, there's actually going to be 2 virtual routers, one for VLAN 10, one for VLAN 20. So let's make that happen. Too much talk? It's all timed out. All right, no errors. All right, let's do show standby. Now we've got 2 groups here, and you can see the status has changed. So this is router 2. So, what are you doing? Oh, that's what's happening. So, on VLAN 10, this is router 2. It should actually be standby. So its state is listen in that, but I think it's actually changed to standby now. I was too quick. And so you can see the virtual IP address. You can see its virtual MAC address is unknown. Now let's do that command again. I was too quick. There we go. It knows the virtual MAC address now. The virtual MAC address is that. And so hello time is 3 seconds. So every 3 seconds they send a hello packet to keep track of one another. Hold time of 10 seconds means that if you go 10 seconds without hearing from the other router, we'll assume it's down, and so we'll take over as active. And so when I typed this command in, it was 2.3 seconds until it sent its, was going to send its next hello packet. Now on this router is not doing preemption on VLAN 10, but it will be on VLAN 20. And so the active router is the other one. So for VLAN 20, this is active as opposed to standby for VLAN 10. Again, we've got the virtual IP address, virtual MAC address, same settings. You can see that active router is local as opposed to active router is an address. You can also see the priority setting here, so 100, and it's 100 because it's default. Here the priority is 200, and that's because it was configured as 200. And it even gives you the group names and everything else. So that looks pretty good. Having a look at router 1, not going to be a lot different. Of course, VLAN 10, it's active. VLAN 20, it's standby. That's the major difference. So now we have that .3, that virtual router for both of the VLANs of .3 active. Now spanning tree, I think I already mentioned this, that I'm going to make core 1 the root of spanning tree for VLAN 10, and I'm going to make core 2 the root of spanning tree for VLAN 20, just to maximise traffic going towards their router. Because core 1 is directly connected to the active router for VLAN 10, that'll work nicely. So of course, I'm going to make core 1 the secondary for VLAN 20 and core 2 the secondary for VLAN 10. So if core 2 were to die, the other one would take over as being root of the tree for both. And of course, it's going to, because that other core is dead, it will be using, HSRP would have already also cycled over to using that other router, because if the switch is dead, the routers can't talk to one another, and so it will have cycled over to the redundant router. So that again is playing into our redundancy nicely. So core 1 is here. Core 2 is there. All right, let's do a show spanning tree. Now, VLAN 1, I haven't configured VLAN 1, so that's still going to be, you can see the root ID is still 32,000. That's because it was switch 3, if you remember. I haven't touched that, so that's just going on. So it's actually G104 that is the root. I suppose if we look at this one here, it's that one. That's because it's directly connected to the root switch. Now, we look at VLAN 10. The root ID is that, but of course this is core 2, so that's core 2's priority. So it's 28,000, it's less than the 32,000, but it's not the root because core 1 has got it better. But if we look at VLAN 20, this bridge is the root, which is what my plan was. And so it's 24,000 for that. And of course, because it's the root bridge, there are no root ports. They're all designated ports. So if we look at core 1, of course, it's just going to be around the opposite way. Show spanning. So, of course, VLAN 1, no different. 32,000s, it's switch 3. Of course, VLAN 10, it is the root. VLAN 20, it is not, it's the secondary. So, that's working pretty nicely. I suppose the only thing I haven't done with spanning tree is I haven't done the port fast or something like that for the host ports. I could, but I haven't. All right, so you will also notice there's no orange anymore. And so different VLANs are using different cables now. And so we've still got our redundancy, but we've also got load balancing. So with a good design, you can use spanning tree and HSRP to not only give you redundancy, but also to do your load balancing. Of course, there is was it GLBP, the load balancing version of HSRP that will do it anyway. but you actually don't need it. If you've got a clever design and a network that sort of works for it, it'll work. And so, yeah. All right, now we're going to do DHCP, just because I didn't want to address all the hosts. And also, well, it is a topic. So, of course, with DHCP, the first thing you do is your excluded addresses. And so I'm just excluded the first 10 usables. Then IP DHCP pull VLAN 10, original name, not. We have the network number. Remember I said that's the one that a lot of people forget? Well, when I wrote this text file, I forgot to put the subnet mask in. So of course that command failed and the DHCP server didn't work. So even though I knew to put the network number command in, I'd forgotten about the subnet mask, and so the end result was the same. Thankfully I'd seen that and went, yeah, dork. Anyway, so of course you need to tell it it's the default router, and of course we've got HSRP running, and so we can use .3. I've done a domain name because I can. I haven't done a DNS server because there aren't any servers on this network, but anyway. Okay, so that's a DHCP server for VLAN 10. Thought I might as well put it on router 1. Okay, we had some cycling of HSRP because I did the spanning tree after HSRP was running, so that probably upset it a little bit. Anyway, so as far as DHCP is concerned, I don't see any error messages, so that's always nice. So of course for VLAN 20, I've done much the same thing, but of course it suits the addressing for VLAN 20. Okay, so let's get some hosts going.
Does that mean if either of those routers go down, that VLAN DHCP just disappears with it?
Yeah, it would. You could put two pools on with different parts of the address range or something like that. You'd have to exclude each other's address range.
Yeah.
Or of course, yeah, you could have a DHCP server that's on a reliable network somewhere. So DHCP is working. Isn't that nice? That was VLAN 20. Let's try VLAN 10. That's working as well.
Why does it say automatic, not DHCP for IPv6? Is it different?
Well, because automatic can actually be SLAAC.
Oh, that's right. There you go. Because that dictates the...
Settings from the router, whether it needs to send a DHCP.
Yeah.
Okay, one more host. All right. So we can do show DHCP binding. IP DHCP. So force hosts on VLAN 10, then their MAC addresses, and so on. I haven't set an release time, so yeah, I've got them forever. So on router 2, show IP DHCP binding. Again, 4 hosts, 4 MAC addresses, all good. So that's DHCP running. We're nearly at the end of our little activity. So, ether channel. So I'm going to say the way I've got DHCP and STP running, actually we may not get a lot of gain out of it, but it's there. There's two links between these two switches. So begging for ether channel, basically. And so here, the ports 5 and 6 are the ones that are between them. So this would be 6 odds. I know, 5 and 6. And so it's the same on both switches. Very handy. I can use this one config for both. And so we make the interface as a member of that channel group 1 in mode active. So again, I'm using... No. That's the one. Oh, it has slipped out of my head, but I knew it wasn't PHP. And so from there, we end up with that port channel interface now. So again, it's on these switches, and so it wants its encapsulation sorted before you can actually put it into trunk mode, but that's all we need to do. So copy, again, paste it into the switch. It's not entirely happy at the moment. Let's get it to sort itself out. I've probably upset HSRP again. So that seems to be running now. So if we do show ether channel, that was a bad typo. Ether channel summary seems to be the best command in my experience. And so we have port channel 1 with the status of uppercase S and U. Uppercase S is it's layer 2. Uppercase U is it's in use. And then the two ports have both got a status of P, uppercase P, which means it's in a port channel. So that's all good. I suppose we could look at spanning tree. That will have changed a little bit as well. Show spanning tree. And you'll notice now that port channel is there instead of the two ports.
The final Prac going to ask us to set a mode for spanning tree. Like in the packet tracer in module 5, I think you mentioned in the email.
You mean set a route?
No, how we can choose like a TVST or
which version of STP to run?
Yeah.
It may well. Okay, so that was pretty much all I was planning on doing. I suppose one thing we haven't done yet is we haven't tested connectivity, have we? Can I ping 200? But 200, 200, got 200, got 200, got 200. First ping that's gone out there might be an ART request or two. Looks pretty happy. Trace route 200. Now it's not showing 10.3, but my suspicion for that is that, of course, that's what the host tried to talk to, but of course it was actually router 1 that sent back the ICP message saying, hey, it's, well, TTL is this one, and so I think that's why. But, so that works quite nicely. I suppose I could do the same on VLAN 20. ping 200. Again, this is a different route, so it's going to be slightly different. I mean, you know, there's going to be ARP requests holding it up. That worked nicely again. And I'm assuming the ICMP will come from router 2 this time, and it did. Okay, so that was pretty much all I was going to demo. Now, of course, it's the original file. Do not save. Of course, as I said, the actual packet tracer test will not be that complex. It won't be that complex at all. And so, of course, next week the testing will be much the same as what we did for CCNA 1. We'll have the theory test, which will actually be a quiz that I've created. Well, I'm in the process of creating, as well as a packet tracer test. And so if you've noticed on the class page that there is actually a section there for semester 1 testing or something like that. And so that's where it will be in amongst that. And so, of course, you'll be on Netacad. So there will be a quiz there. It's hidden at the moment, and also it's not finished. But so there's a quiz, and there is also the packet tracer that will be available there in a folder. So it'll be much the same as before. I'll send you an email address with a unique number on it for your addressing scheme, and then from there you'll need to then do certain tasks, create VLANs, do inter-VLAN routing, spanning tree, ether channel, all kinds of things like that.
How complex should we do the basic config? Just host name, or do we have to do the one that we did last?
I won't be quite as nitty-picky about passwords and things like that. I might get you to put passwords on maybe one device just to remind me that you know how to do it. But yeah, apart from that, yes, if I don't tell you you need to do it, you don't need to do it. So I might say on router 1, you know, do an enable password and a console password and this and that and everything else. All the other devices I probably won't. Just because it'll make it a bit quicker for you and less hassle for me to market as well. Yeah, I always have a text file with the passwords in it and just paste it in. Now, so that's basically how it's going to run. So there'll be a 10 o'clock session, but that's not you guys. You'll do the 12 till 2 again. Yeah, so 10 o'clock till 12 for the group that normally starts at 10 because they are bigger. And then there's the 12 till 2, that will be the other session. So that is the plan.
And you'll let us know when the Prac test and that's up on Netacad?
Yeah. There's a practice. Well, yeah, there's a practice theory, but that's for the entire course. So I might have to put up a little. Oh my God, the work is mounting. I will, in the next day or two, I'll give you a message with whatever practice activities there are available.
Sure.
All right. Okay, so are there any other questions?
So the same thing as last time?
Pretty much the same thing. Theory test first, then the practical.
And a couple extra activities for bonus points.
Yep.
Cool. And that'll be like from what was included in the course materials?
Yeah. Only from the chapters that we've done, up until chapter 9.
Yeah.
Which is why it's making it a little bit complex for me to do practice ones. All right.